we've seen in class a fair amount of confusion about the numbers of elements in various intersections and unions of sets. So we're going to try to use a notation that your text doesn't use to understand this a little better. If you have two sets A and B, then there are four regions formed if you do a Venn diagram, a general Venn diagram. We're going to number those regions with Roman numerals. Roman numeral 1, Roman numeral 2, Roman numeral 3, and Roman numeral 4. These sets, well, comprise the four regions, and they can be named in terms of intersections and unions. For example, region 2 here is A intersection B. It's the intersection of the two sets. Region 1, as you should be familiar by now, is A minus B, the elements of A taking off whatever happens to also be in the element B. And here's B minus A. And this set could be written as A union B prime, or, if we wish, A prime intersection B prime. Remember De Morgan's laws and why they hold. Now, the set A union B. What's a set A union B? That's what we get when we put all these two sets together into one, so that the set A union B just comprises everything inside of these two sets. That is the union of three subregions, the first, the second, and the third. A union B consists of these three regions. So we could say that A union B is region 1, union region 2, union region 3. Represented by the union of those three sets. The equality here is being used a little bit loosely, and I'm usually kind of a stickler for that sort of thing, but I don't want to confuse the issue at this point. Now, number of elements in A, well, how many elements are in A? If we know the number of elements in regions 1, 2, 3, and 4, if we knew the number here, the number here, the number here, and the number here, how would we find the number in the set A? You should answer that for yourself before you hear me answer it, so pause if necessary and ponder that question. Okay. Region 1 and region 2 make up region A, so if we know the number in region 1 and the number in region 2, that's all we need to know the number in A. Similarly, region B, the number of elements, or the cardinality of the set B, is the number of elements in this region plus the number of elements in this region, regions 2 and region 3. What's the number of elements in A union B, the union of these two sets, if we lump all this together? Well, it's the number of elements in region 1 plus a number in region 2 plus the number in region 3. We add the numbers in the three regions to get the total number in the set, in the union in this case. So let's just see how that comes out if we write it. The number of elements in the set A is a number of elements in region 1 plus a number in region 2. Number in B is a number in 2 plus a number in 3. What's the number in A union B? Well, we add the number in 1 to the number in 2 to the number in 3. Now let's contrast that with what we get if we add the number in A to the number in B. If we were to do that, we would add the number in region 1 and the number in region 2, that's region A, and then we would add the number in region 2 to the number in region 3 for the number in B. And this region 2 would get counted twice. The number in A plus the number in B then is a number in region 1 plus a number in region 2, that's a number in A. And then the number in B is a number in 2 plus a number in 3, and you see we got the number in region 2 twice. What do we make out of that? Well, the number in region 2 is a number in the set A union B minus the number in region 1 minus the number in region 3. And actually, let me go back. I kind of jumped ahead a little bit there, and that might not have seemed to follow. Okay. In this case, we see that the number in A plus the number in B is greater than the number in A union B by the number in region 2. From this, we can conclude that the number in A union B equals the number in A plus the number in B minus the number in region 2. Now, region 2 is just the intersection of the two sets. so that this is the number in A plus the number in B minus the number in the intersection. This equals this. Now let's look at what else we can draw from this picture. First of all, if we want to get the number in region 2, what do? We can take the number in A union B, which is everything lumped together here, and subtract off the number in region 1 and the number in region 3. So the number in 2 is the number in A union B minus the number in region 1 minus the number in region 3. Now region 2 is just A intersection B, so the number in A intersection B equals this. Now what's region 1? We see that region 1 is A minus B, region 3 is B minus A. So we can just take the common sense of what adds up to what here from this picture, and we can write that the number in A intersection B is the number in A union B minus the number in A minus B minus the number in B minus A. Similarly, we can say the number in region 1. Now let's just see, how would we get the number in region 1 if we knew the number in the union and the number in the intersection? So if we know how many there are total here, that means we know what these three add up to. If we know the number here and the number here, we can easily find the number here. The number in the region 1 is the number in A union B minus the number in region 2 minus the number in region 3. Of course, region 2 is A intersection B, region 3 is B minus A. So by using this picture, hopefully you can make a little more sense out of some of the problems involving numbers of elements in various sets.